Hello? Can you guys hear me?
Yep, what's up?
Oh, hold on. Connect AirPods. There we go. Can you guys still hear me?
Yep.
Okay, cool. Uh, Today we're also gonna do the paper review. It's also gonna be streamed on X, I guess. So just letting you guys know. Does anyone want to present or should I get started? Oh,
You
assuming.
can start.
Yeah, I'll start and then we'll get talking about it. Share my screen. Okay, so I guess this will just be explaining the intuition behind the paper a little and uh, I guess my understanding of it. So I guess back in the day there was these things called RNNs, which I feel like people still learn about, but it was basically, I guess we had a piece of text like I have a cat, and they wanted to translate this. Let me get a little more space between these words, and the goal was
Big
to,
section view allow you.
what was that? Oh, there we go. Uh, So the goal was to translate this text into a different language, so say French or English or whatever. I mean, it's already in English, but so we would take each letter or each word. It would go through an encoder, code, uh, and then it would be that encoder would be placed into a model. This was an RNN or an LSTM or whatever it was, RNN, uh, and it would output the next element. So that would be, let's say, RNN1. This would be the second, or RNN2. I think there's actually better, definitions for these. And then each time it will pass a hidden state, basically a memory, and it would say, okay, this will be H1, this will be H2, and so on for each. Uh, but the second one will take in this is an input and H1. Usually it starts with H0 as well, but just the zero vector. Um, and this will continue on until, I guess, the whole sentence is encoded or into the model. And then it will get to the decoding layer, which would probably be like that. So it would flow there and it would try to translate the first word. So this would be decode. And this would translate the word I, or like the first element of this first word in the new language, into French I don't know French, so I'm gonna leave it like that. But the issue with this format was it basically had to the I had to go through all of these layers and then get decoded. It would be the same structure, so it would pass H, say 4 into the new decoder. So it has to pass through all these layers. It has to go to here, go get past, that information needs to be passed through all these hidden states, and especially for a long context, it was like this model, this RNN model was just not working out great. That's, yeah, basic RNNs very quickly and roughly. So the whole idea behind attention's all you need was, grab this, the translation, the translation shouldn't need, like, every word in the translation affects, I think I put this nicely, you basically have a attention mechanism, or we have a model. And the model should basically be able to take in all these elements and translate them, and for each token prediction, it should be able to look at different parts of speech. So for the first prediction, let's say you're trying to predict the first word into French, theoretically you're going to have, ideally, you'd look at all these words and you'd weight each of them slightly differently. So maybe the word I is 90%, and the word have is a little less, and maybe A isn't so important for predicting. I mean, I guess you'd be predicting the word have, but still, because you have to start with an initial value. But basically, you have a weighted sum of the importance of each value, and then you do this with the next word and the next word. I guess this is the main thought process behind, attention. That's the attention mechanism, at least vaguely speaking. But then we get into actually how they did it. So we'll go through. Anyone have any questions, or do you think I messed up something here so far?
No.
Okay, yeah, sounds good. So the attention mechanism, basically let me grab my test sentence. I have a cat. I do not have a cat, by the way. And each word is going to get encoded. So you can have encoded, code 1, coding 2. I mean, there's also tokenizing, because you can't go from words directly to to encodings, but we're skipping that for now. And so on. So every word gets encoded, and there's basically 3 outputs for each encoding. There is the key, there is the value, and there's the query. And each element here basically tells us something else about, basically it's asking a different question of this word. So for instance, the key is saying, let me think again, I always forget. The query is basically asking, what am I related to? Like, what relates to me? The key is, I relate to blah, blah, blah. And the value is, I am. Basically, this is my actual meaning. I am something. This is my definition. So for instance, like a cat, you could say, a cat is an animal with 4 legs, and that would be the value. What do I relate to? So it's trying to be like, yeah, I mean, this is my understanding of how this process works. It's a little, I guess, an intuitive understanding of it, but I don't know if it's actually what the authors had in mind. But basically how this process works is you take every query, you start with the query of, let's say, I, you take the query vector there, and you connect it to every key. So you say, Q1, am I related to K1? K1 would be right here. So the I encoding with the key. And then you could say, okay, Q2, and that would relate to K2. My bad. We take every query, basically every word, and we connect it to every key. And we do this for every single one of the words in the sentence. And from there, we would basically get, we'll get a value, we'll get basically different values because we're dot producting these together. And we're saying, okay, this is, basically each of these get a score on how similar they are. So I relate to X, I'm related to Y, and if those things are very similar, you'll have a higher score. We throw these results into a softmax, we get a distribution, so let's say 0.7, 0.2, and 0.1, meaning, it relates a lot to K1, not so much to K2, and not really at all to K3. We take these values and we multiply it, or we dot product it with the IM value. So it's basically saying, I am this, and I relate to, so this would be I am this, and I relate to this word, and that word based on these percentages. Yeah, that's my understanding of attention. Anyone have any points or questions about this?
I have a question.
Go for it.
So can you elaborate on what is Q value and Q query exactly?
So basically, I guess the encoding gets like there's three, I guess, versions of the encoding. Also they get in later, but there's three versions of the encoding, and they basically want each part to focus on something else. So the first portion, the query is what do I relate to? So, here's a better example. I went to the bank to get money. So if I look at the word money, it's going to relate heavily to, the word bank because, or if I look at the word bank, it's going to, if I look at money, it's going to heavily relate to the word bank. So what am I related to? Money is related to bank. So theoretically that Q value should be talking about, or it should have its vector of the Q value should relate heavily to bank. Maybe not the actual value of money. Like the word money doesn't relate to bank super. It does, but it's basically, trying to think of a nice way to put this, but I don't think I'm doing a good job. Does anyone else have a different understanding about how the Q value, the query value and keys work? Because this is my understanding. It's basically splitting up the encoding into three questions, and each one is supposed to represent a different thing. But, so the query is what am I related to? So the money is theoretically related heavily to bank. So if I'm, I guess, in a word prediction setting, I'd be looking at different words and try to predict the next word. This, opacity, we wouldn't get as much value as this. But, yeah, in my mind, so every word, let's say we did a word encoding, each word would be encoded and that would just be the value. It's like, hey, this is what this word means. The query is, what do I relate to? Like which words, I guess which words are like related to me more. And then the keys are I relate to. So say being like money, hey, I relate to this. And then the queries are, I don't think I'm doing a great job explaining this, but let me know if you got any of that.
I mean, like, matlab, I think the query is exactly what you said, like how you can relate, right? Matlab, for example, for any word, like uh, how, matlab, what is that particular word looking for, or something like what you did, or what you told, like what am I related to? But key should be something like what that particular word has to offer, right? Like the info that that particular word contains. Because you are comparing key with queries, right? And then you are using your value.
And using your value. So
Right?
you're saying key is more related, more like what the actual word is?
Yeah.
Okay. But then I
Or
guess what would value
maybe,
be? Because I feel like value in my mind is like the ending value of like the word I gets encoded into this
I
set
think
value.
value should be, yeah, value should be the, uh, like if any particular word finds that particular, finds another word more related, then if it asks for information from that word, then value should be that particular vector that another word should send to the word that finds it more related.
Okay, I see what you're saying. I mean, I guess all of this is sort of, you know,
Yeah,
and more of an
all of them are
intuitive
same.
understanding of,
What you,
yeah,
yeah.
we could go through the actual, I mean, I just wanted to go through, I guess, the attention mechanism, which I feel like was the main portion of the paper. Let me actually pull up the whole paper. And they also add, I mean, intuitively, I understand what they're doing. Basically, if you encode everything, the positional elements get lost, which is here. And that's why they add back in positional encoding into the regular encoding. Their positional encoding is, in my opinion, pretty weird. I know they use like cosine and sine, and I don't fully understand it, if I'm being honest. If anyone has, a good grasp on it, I'm more than happy to, listen to it. I mean, it's not super important. I don't think it's used a lot today, but it's basically they added a positional encoding to the embeddings because when you embed each word, the embeddings don't contain positional information. Other things about the model, I mean, I guess it's pretty interesting here. I think, I'm trying to remember what these arrows were, because I know it takes 2 from the encoding layer and 1 from the output layer. I'm pretty sure this is the key value. This is the query, if I'm not mistaken. Yeah, pretty sure that's the case, but yeah, I mean, I just wanted to explain, I guess, the attention mechanism. This is a nicer formula. They do this just for a little normalization. But does anyone else have any thoughts or questions or interesting points about the paper? One question, I mean, I think next week maybe, I mean, I know we have to decide what we're doing next week exactly, but I don't know what it will be. But in my mind, I'd like to see, I guess, a more recent paper so we could take the contrast. We might do flash retention. Either do flash retention or we'll do a more recent paper where we will basically see the difference in the architecture of attention now versus the architecture of attention before.
Yes, it can be interesting. And furthermore, there was a problem actually on DeepML who was talking about actually skipping normalization, and I think it was related to some sort of weighted softmax. Tangent, hyperbolic tangent. I don't remember where the paper is from. That could be cool to actually compare the classical transformer-based mechanism to actually more recent ones.
Yeah, see, is it still even need? Yeah, I think that's a good point. Was TANH? I remember reading that paper a while ago. I just don't remember exactly what was the point of it. TANH.
Yeah, it was actually like skipping normalization layers, and I think it made things go faster.
Do you know if I wonder if it's you? Some of these questions I have for, I guess, like OpenAI and things like that. Like, I wonder, do they use hyperbolic tangent? Like, what's the actual cutting edge? And because even like open source models, I feel like they don't share how they're training these things. I mean, sometimes they do. Sometimes they'll give us some glimpses at it, but I feel like they don't give us everything. Like, when there's hyperbolic tangent still used, do they have a better method now? I don't know.
Just a doubt. Locke said that removing normalization layers made the overall architecture model, whatever it was, faster. But isn't it the other way around? Like when you add normalization layers, of course, for each epoch, the model becomes slower, but for the whole like for the whole training time, it kind of decreases. Just
That's interesting.
that's what I wanted to ask. Like,
Oh, I thought you were just stating that it decreases. But you're asking, is it if we remove the normalization layers and just have the 10H, does the results degrade over time? Is that the main point, or did I miss it?
Yeah, I just found the paper. Actually, it was Meta Team Fair who did the paper. It's named Transformers Without Normalization, and actually in their conclusions, they said that under some settings,
Hello.
training a model without normalization layers can match or exceed performance with the dynamic 10H, and it makes training go smoother, as I said earlier. But yeah, it's more modern approaches, and where they try to discover how to make things go smoother.
Yeah, it sounds like a pretty interesting paper. Maybe we'll do votes based on, we'll just do a vote for the next paper, because I know some people wanted to do uh, flash attention as well. But yeah, we'll just do a vote every week, and we could, whoever wants,
All right.
we'll have like 5 or 6 options, or we'll do 5 options. And whichever one wins, we'll do the following week. I'll try to make anyone complete the collection on DeepML.
yeah, I wanted to ask, like, if it is possible that maybe you can, like, you will again convert that collection from free to pro, right?
I could leave it open for a
So
few more
if it is,
days.
yeah, that's what I wanted to ask.
Yeah, no problem. Yeah, and ideally I'll create, whichever paper we work next, I'll try, my goal is always to try to create a collection based on it. This way everyone could work on it and we could all work on it together, but sometimes I just don't have enough time. Anyone have any issues or enjoying something on DeepML and want to let me know? More the issues would be helpful, but the nice things also help.
Hello, am I audible right now?
Yep, you're audible.
Yeah. Sorry if I have some background noise. Just ignore it for a second. So I just dropped you a DM about something very serious. Can you just check it?
Oh yeah, I saw on X you dropped me that DM. I think I replied back to
Yeah.
you. We're working on fixing that right
No,
now.
no, no. Not on the Twitter, on the Discord itself.
Oh,
I
oh
just
yeah,
texted you half hour ago. Yeah.
oh yeah. I just saw it. Okay, we could talk about that, I guess, on chat.
By the way, sorry if I'm creating a nuisance out of it. I just want, because you helped me in my ML prep, so I just want you to help that.
No, yeah, again, it's I appreciate when people, tell me when things are wrong, because that's the only way we get better. Like I could just ignore everyone and ignore everything and be like, oh, DeepML is amazing. If people say anything bad about it, they're just haters, and but then the platform would suck, and it would, yeah. Right now we have bugs and we have issues,
Yeah,
so yeah, I thank you for
yeah,
pointing them out.
yeah. I understand, like, it is a bit difficult to make it properly safe, but yeah, it's okay. It happens.
Yeah, and I appreciate, yeah, in my mind, if people contribute questions or people just say, hey, I hate this feature, or hey, I love this feature, all feedback to me is, or I try to make it feel the same. It's sometimes hard to look at, hey, you did this wrong, or hey, this is stupid, and I'm like, yeah, a little bit. Sorry about that, but I need to try my best to accept the critiques and move forward.
It's not about making something wrong. It's just that I just hope nobody will find it first and they will not create a disturbance or something like that, or like being an
Yeah.
obstacle to everybody else. I just wanted to prevent it. Yeah.
Yeah, yeah, I agree. And we should have it fixed either today or tomorrow. But yeah, thank you for bringing it to our attention.
No, no, no. I'm not talking about the previous part. I just found something very interesting or something very bad. So I just wanted to let you know that. So we can have a short 5 minutes call. I can just share my screen and tell you that part.
Okay, yeah, we could. Maybe we'll set up some
Yep.
time over chat and yeah, sounds good.
Yeah. Works for me. Works for me. Just let me know whenever you are free. And sorry for disturbing the class. The
No,
paper is very good. The engine is all you need.
yeah, I feel like usually the second half of these usually just becomes either random rants or random conversations. So if anyone has any thoughts or read anything interesting over the past week, go for it.
Sorry, I lost you on the last part. What you were saying.
I was just saying, we usually the second half of uh, the weekly meetings, we usually become not about the paper we read, usually just random conversations. But again, if we want to cut it off early, I'm good with that as well. Um, yeah, I mean, I saw on Twitter we had a poll for what library we should support next or language we should support next. I think CUDA won, so I need to start getting better at CUDA and start making our system be able to handle that.
Okay. By the way, I have an interesting proposition or a request for you. I saw you added a tiny grad, which is very like appreciable thing. Like hardly people go for that route. I was trying to create a similar thing, machine learning library. If it is like a production ready thing, maybe you can add a feature flag if anybody wants to write it in that language. Is that possible?
Yeah, I mean, yeah, it's definitely possible. I think it's just, I mean, right now I guess we're doing it based on user demand more than anything, but yeah, it sounds interesting. Sounds like a cool niche thing to have, and
Yeah.
yeah,
I totally get it. It's totally like up to you. Sorry, just give me.
no, yeah, sounds cool though.
Yeah, I mean, if people or user wants it, that's like well and good. Otherwise, we can just drop the plan. That's not hardly possible.
Yeah, keep me updated on it.
Appreciate, man. Good. Thank you
Uh,
for like talking.
um, how's everyone enjoying
I just
the?
wanted to
Oh,
ask,
go ahead.
yeah, yeah, I just wanted to ask like what you said, like when will be CPP and CUDA support will be there?
Um, so the way I guess it's me and one other person that are currently running this, we do it based on monthly sprints or whatever you want to call it, like monthly working things. So hopefully next month we'll carve out some time to at least start supporting it. Maybe we'll have the first 5 questions with CUDA implementation, and then we'll open it to the open source community and see if people want to help, you know, convert more of our questions to CUDA. This way we could have like a slow rollout of these questions rather than having to do all 200 questions in CUDA because that would take a really long time. So hopefully next month we'll be able to implement it. That's my goal right now.
And CPP as well.
What was that? Sorry, I didn't hear you.
CPP as well. CPP.
Oh, CPP. It probably will go. I mean, I'll make a the same poll in Discord. But at least on X, it seemed like CUDA was first. Let's see. I think people also wanted me just to finish on TinyGrad and PyTorch a lot. Yeah, it was CUDA, Python with no libraries, so you know how right now I allow everyone to use NumPy, at least, so apparently a lot of people also want the Python, but no libraries, which sounds really intense to me, but sounds fun as well. Then people want me to finish TinyGrad, and then people want me to work on C++, but I could do the same poll in Discord and see if there's any different results.
So,
Maybe add them all together.
just to be clear, you are saying that people want there to be Python but without any libraries, right?
Yeah, I mean, that one should be pretty easy, but I mean, I gotta convert the questions, I guess. They want CUDA,
That's
Python no libraries, finish PyTorch and TinyGrad, and C++, like last.
yeah. Python without libraries is kind of C++.
Yeah, it's relative, it's pretty
Kind
close
of.
to it. Yeah, I feel like those things are relatively similar. But I
Yeah.
feel like, yeah, all those questions, just Python, will be, I feel like that just makes everything a lot harder, which sounds fun. Because sometimes, you could just, like the whole reason we only have NumPy is so you can't just go import np, or import scikit-learn. Like, we only have NumPy so you can't just go import scikit-learn random forest, and then, I know how to use a random forest. So, I think just Python would be a similar idea. But even CUDA will have a similar idea, and C++ would have a similar thought process as well.
But like,
Go ahead.
what's the difference between Python with libraries and without libraries? Like, if somebody doesn't if somebody doesn't want to use libraries, they can just simply write the code in Python in whichever way they want, right?
Yes, but I guess it sort of, like, I guess you get different amount of flame points if it's a hard question or an easy question. So if it's just Python, I know it's a lot. I guess I'll change up the difficulty because I know you can't really vectorize stuff by yourself. Or I mean, you can, but it's a lot harder. I guess the questions all become. Side note: are people liking? I want to add, yeah. For the labs, I have a few more questions I wanted to add, but I need to add GPU support for them because it takes like 3 minutes to validate it, and I feel like that's just too long for people to wait to see their results. So I need to work on, yeah, I guess GPU support for some of these questions. But are people, we have I guess a competition running this month, if people aren't aware. If you solve, I guess, the second lab question, and you're in the top 10 percentile, and you post it on either LinkedIn or X and tag us, you could win a sweatshirt from DeepML. But yeah, just wanted to let people know that, and also see if people are enjoying the labs. I'm gonna assume people
And
are some.
you also, yeah.
I was going to say, I assume people are somewhat liking the labs. To be honest, I'm probably still going to spend more time on it. I mean, I hope people are enjoying them, but to me, it just feels like not a better question. It tests you on a different. It helps you learn PyTorch or how to actually implement things, and our basic problems help you understand things on a deeper level, which I think are both very valuable. But I've been enjoying making lab questions, so I probably will spend a little more time making them.
Yeah, like the concepts that we have shown in labs are somewhat asked in interviews as well, so I think it's good.
Yeah, I think so. Yeah, and I feel like they're. I don't know. Yeah, sometimes I feel like maybe like right now most of our users use problems, and some use labs, but sometimes I feel like you have to just say like F it, and I think labs will work out better than I don't know better, but at least on par with problems in terms of user engagement. And if I'm wrong, then I learned a bunch, and if I'm right, then we get more users or more engagement or whatever. But yeah, we'll see how it goes. Okay, guys.
And that job section that you added,
Mhm.
is it something that you added on the site right in the past 2 3 days, or was it there before as well?
It was just yeah, I think like 2 days ago.
Okay.
And we plan, I mean, this will probably be a premium feature, and when we get more jobs, maybe we'll make a free tier as well, but basically have, based on the job description, recommend questions that you should solve based on this job description. Like, oh, hey, if it's Google DeepMind and they require this, this, and that, we'll recommend, hey, you should you should solve this and this question for preparation for that interview. But yeah, but we'll see how that does as well. I mean, we're also trying to get funding. I think I mentioned this last time. We're trying to get funding now, so that also is eating up a nice amount of my time. So I'm sorry if the other things are a little slower.
Hello. Like, is the core platform open source? Like, will I be able to contribute?
So the problems are open source. The actual website isn't. So like you could add questions or you could write issues about questions, but the actual site is not open source.
Okay, okay, interesting.
Yeah, I was trying to think how I could make. I like the idea of open source. So I was trying to make it as open source as possible while still having a business.
Yeah, obviously, you can't just go and open source the platform. People will be copying your platform. That's fine. I can
Unless
understand
you are
that.
a billionaire.
What was that?
I was saying you can open source it unless you are a billionaire or something.
Yeah, I was like, ideally I would be able to open source it, but I'm like, but you know,
Yeah.
maybe
Yeah.
one day. I think
Yeah,
in case leak code or someone just like steals the business completely and just like destroys us. I think we'll just be like, okay, we don't have anything to lose, might as well open source it all. So yeah, if we fail, I guess we become open source and hopefully we'll be able to compete with the help of the community. But right now, we're doing well and hopefully we'll get funding and we'll be able to build this into a better platform.
yeah. I mean, if you need a developer or just to do a side as a side project, just let me know because recently I just resigned from my previous job, so I'm just trying to explore different things.
Okay.
Be free just to work.
Yeah, I'm
Yeah.
hoping.
I mean, without any incentive, without any strings attached, straightforward.
Um, okay. Yeah. I mean, we'll definitely. Yeah, definitely. We'll let you know and we'll talk and we'll chat.
Yeah, I mean, I mean that's very what we can say. It's very unorthodox thing to ask for, but yeah,
I get you. I mean, hopefully, yeah, hopefully when we get funding, we'll actually be able to hire some more engineers and stuff, and we'll do interviews and that whole
yeah,
process. And
yeah.
yeah, but we're in the early stages of
Gotcha.
DeepML. Yeah.
By the way, I will just share you the recent finding. Just go through it and just let me know whenever you are free.
Okay. Yeah, we'll do. Okay.
Yeah, it's kind of a business critical thing because I was building with pro subscriptions and all. So I hope you'll understand.
Yeah. Yeah, we'll chat about it, I guess, soon. But I have to drop right now. But thank you everyone for joining. Uh, Ruchtia, sorry if I'm
Yeah,
mispronouncing your name. I just saw your
yeah,
messages on the chat. Uh, yeah, I get you.
yeah. By the way, thank you for entertaining. I couldn't ask for more.
No, yeah, no problem. Um, I'm just reading through your comments right now. Yeah, maybe a list of questions we should all try to understand would be a good idea for the future. Or something to make it a little more interactive. But yeah, I gotta drop off, but let's chat in the chat, I guess. But thank you guys again for joining, and thank you for the engagements.
Yeah. Bye.
Yeah, have a good day, guys. Bye.
Bye bye.